All right, let's get right to it. Graphing inverses. Okay, this is page 18 in our yellow notebook, so you can pause real quick and get that on there if you need to. Let's see. So when we're graphing an inverse relation, okay, we went over this on Thursday in class. You can reflect each point across the line y equals x. That's a key line there. Okay, that's that linear parent function. That's where we're reflecting everything over to get to an inverse. Okay, this is equivalent to switching the x's and the y's. So it's the x values and those y values. So you basically just switch them around. Okay, so you're literally just switching around your x's and your y values. Exactly what we were doing on Thursday in class. So we basically have got a couple things going on here. We got already, it shows us our function. Here's our function right here, f of x. There's our function. Okay, there's our function. And we've got all these points, 0, 1, 2, 4, 8 for our x's, 2, 4, 5, 6, 7 for our y's. And then we've got the inverse table. So remember, our inverse is going to have switched x and y. So here, the y of 2 becomes the x2 for this one, for the inverse. The 0 for x on the original function becomes the 0 for y in the inverse. So inverses, real quick. This notation right here, this f to the -1, that's actually, here, let's zoom in a little bit more. That's actually the symbol that we use for inverses. So the inverse is like the f of x, but instead it's got this little like -1 up there. Okay, so that's what we're going to use for our inverses. That's kind of like a notation. It's like a nomenclature thing. Okay, so that's something to keep in mind as we're going along. Okay, what we can do is with this table, we can go ahead and fill in the rest of the points because they got the first two for us for the inverse. So, you know, this point became here. We got 1, 4 became 4, 1. 2, 5 is going to become 5 and 2. Okay. 4, 6 is going to become 6, 4. Okay. And then 8, 7, that guy's going to come over here and become 7, 8. So if you look at this, all of our x's, okay, have now become our y's, and all of our y's have now become our x's. So that's our reversal. That's our opposites. That's how we flip from one to the other. Okay, let's go ahead and we can plot these guys in here. Let's see what kind of shape we end up getting here. Let's see what we get. So 0, 2. So 0 for x, 2 for y. So that put us here. Okay, 1, 4 be up here. 2, 5, 2, 5, just like that. And then 4, 6, like that. And then 8, 7 would be over here. 8, and then 1, 2, 3, 4, 5, 6, 7. So right there. Okay. So we got this kind of shape going on. I've got this kind of shape going on. Okay. So it looks kind of like that. Okay. So that's what we got going on here. That's our original function. That's our function. Okay, that's our function. From here, what we can do is, okay, let's actually put in y equals x. I'm going to use a different color. I'm going to use purple. Actually, no, I'm going to use pink instead. Pink's lighter. Okay, y equals x. That's that parent function for the linear parent function. That's just right here. I'll put it in as a dotted line. Doesn't have to be perfect. There it is. Okay, just giving us an idea of how that reflection works. Okay. For my inverse, I'm going to use purple. It's just a different color. I don't know. It makes it easier to see. Okay. We can plot those points. 2, 0. So careful. That's 2 for the x, 0 for the y's. Okay. We got 4, 1. 4, 1. 5, 2. I'm trying to be really careful. I'm trying not to mess up here. 6, 4. 6, 4. Or 7, 8. Yeah, talk to fifth period about me messing up. All right, so we got something like this. Okay, so notice I want to point out a couple things. This is stuff we kind of talked about on Thursday. Just want to reinforce it. If we're looking at, you know, this sort of, you know, we're looking at our shape here. Something I noticed is that when we cross this line y equals x, okay, our linear parent function here, our two graphs actually cross on that point. Okay, so they actually cross on that line y equals x. All right, so that's an interesting feature. Also, the one is mirrored over to the other. Okay, That's one of our properties of our inverses, is that they mirror over the line y equals x. Okay. So then we can take a look at this. So over here we've got, let's talk about domain and range. If we're just talking about let's say like a bunch of points like we were doing before. We were doing on Thursday. We just had a bunch of random points. It's kind of like a pie, like a pizza shape. I don't know. We just had a bunch of points. We just kind of listed out the x's and listed out the y's for domain and range. For this one though, this is actually a function. Okay, this is one of our parent functions, and hopefully you guys can recognize our original function and what that guy looks like. Okay, so we can take a look at that. But looking at the domain of this guy, he starts at 0. Okay, so he starts at 0. So the domain of my original function, I might as well just zoom out a little bit. Domain of my original function would be 0. Okay, we'll put the brackets because it's a solid dot. Okay, comma. Then what happens is I got an arrow going right. Okay, arrow right means infinity, so that's positive infinity. So we go from 0 to infinity for my domain, for my original function. Okay, let's see, I used purple. Yeah, let's do that. My domain for my inverse. Okay, my domain for my inverse. Here we start at 2. Okay, that's our smallest x is 2. So I'll say 2, comma, and then we'll go, okay, we're going up here. We got an arrow, but it's like an arrow with that slight tinge to the right. So it's going to be to infinity. So 2 to infinity. Okay, so it starts at 2, goes to infinity. Okay, let's do our range for this guy. So our range here for f of x, that's our original function. We'll look at this guy. We start here at 2. Again, now we're talking about how low we go to how high we go. So we go from 2, and we'll put that bracket because it's a solid dot. And then we got this arrow here. It's mostly going to the right, but it still goes up too. So we'll put positive infinity. Okay, so we'll put positive infinity. Okay, let's talk about the range of the inverse. Okay, remember that -1, that means that we're talking about the inverse. Okay, so the range of the inverse. We start at 0. Okay, we go all the way down here to 0. And then we go up to positive infinity. We got this nice little arrow going straight up. Well, not quite straight up, but it's going up. So 0 to infinity. So what I want to point out is something I pointed out last week when we were working on Thursday, is that the domain of the original function turns into the range of the inverse. Okay, see how those match? Okay, and then so here we'll put stars by these guys. These guys match, so we'll put stars. The domain of my original function becomes the range of my inverse, and then for my range of my original function, 2 to infinity, that becomes the domain of the inverse. So we'll put little smiley faces on that one because those guys match. Okay, so domain and range, those flip-flop. Okay, one last thing I wanted to throw out here before we start talking about inverses of parent functions is this. My x-intercept for my inverse, that was my purple one. Okay, my x-intercept of my inverse becomes the y-intercept for my original function, or vice versa. We could say that y-intercept of my original function becomes the x-intercept of the inverse. So these features, all these features that we learned about in this last unit, when we talk about inverses, it's like they flip-flop, they reverse. They're like, it's like the ones become a reversal of the others. Okay, so from here, what I wanted to do is I just wanted to point out something about these parent functions. Some of these inverses of these parent functions actually turn into other parent functions. And so I want to point out one example, and then I want to give you an opportunity to look for some of your own. See maybe if you can find some of your own, maybe, or something. I'm gonna flip over to our page with our exponential and our cubic and our quadratic and our linear. So this is our first kind of thing. Let me adjust here for a second. If you could bear with me here, look at my arm for a second. I want to go down here to cubic. Let's look at him. Okay, let's look at him. So we had this space down here. We had this little space down here. I don't know if you guys noticed this, but we kind of ignored it. I kind of left it be. I said, okay, we have our graph, our parent function, key characteristics, okay? We had our graph and table down here. There's this space for the inverse that we kind of just ignored. We kind of just left it alone. No longer. Okay, we're in inverses now. So, hey, let's take a look here. If we wanted the inverse of my cubic, what we can do is we can switch x and y. Okay, so this point becomes 8, 2. 1 and 1 switch. I mean, that's just 1, 1. 0 and 0 switch. 0, 0. -1, -1 switch. I mean, they're the same thing. I mean, that's not going to change. And then -8, -2. So that's how all of my points would flip. My x's become my y's, and then my y's become my x's. Okay, so they flip-flop. So let's plot the inverse and see what we get. So we got 0, 0. Let's look at that. 1, 1. Man, this is kind of blurry and small, but that's okay. Let's see. 8, 2. Let's see. 1, 2, 3, 4, 5, 6. Okay, so we'll be out here. We're off the charts. We're off the charts. Okay. -1 would be right here. Okay, and then we have -8. So same thing. I got 1, 2, 3, 4, 5, 6, 7, 8. We're kind of off the charts again. And then -2. So that would actually be down here. Okay, so then this guy looks like this. And that's another one of our parent functions. That's literally another one of our parent functions. Okay, which one was it? Which one is it? Or which one is it? Not which one was it? It's cubed root. Okay, see, they're inverses of each other. This guy down here, that look familiar? Okay, he's right here. Look at that. It was one of our parent functions. So the inverse of a cube, the inverse of our cubic, the inverse of our cubic, okay, is a cube root. Okay, some of our parent functions turn into, when we take the inverse, they turn into another parent function, a different parent function. Others, very special one, turns into itself, and then others turn into something completely different. So it's all just based on what they are and what their pieces are. Some turn into kind of something else. It's kind of interesting. We'll take a look at that as we're going along. Okay, thanks for following along with me. And for my particular students, sorry I'm not there on Monday. I'm driving back from a wedding in New Orleans. So there you go. All right. Have a good one, guys.